So we made our Star of David. We've gotten to 3D. So we've gone from dots to lines to areas, flat planes. Now we have a container. And let's again go to our this is our other way of getting there. We can do the same operation that we did before to get from line to square. We just slid it right along, right? And so we do the same thing with a square. We slide it along and we get a cube. Same thing with the triangle. If we just twist it, pick one point to rotate it around and twist it, and we end up with a tetrahedron. And it takes a little bit of mental imagination. So I encourage you to sit with this and actually work out, do the visualization to work out how we get from one to the next. And I couldn't find a visually pleasing way to show how to rotate a circle. But you can imagine if you've got a circle and you spin it, you've created a sphere, right? So that same just rotation process gets us from 1 to 2 and from 2 to 3. Again, super basic. But this is where I want to show you, like the image that came up for me is this process. Like, if you ever watched crystals grow, it's sort of like that. I'll just look at this for a moment, where you see like cubes being created, right? And like, what's happening there other than squares sliding in a messy way, right? Because time is passing, so it's messy, it's not archetypally perfect. And like, what do we have here but lines that are ultimately sliding around and relating to each other, and they're going to create triangles which show up as chords, right? So I mean, this video is mesmerizing, and it goes on and on. But this is the image that is a very like concrete expression of these very simple geometric principles at play in reality, right? And here, we've got triangles that are just changing shape, relation to each other, and creating tetrahedral structures, right? I don't know what's happening. Oh, more cubes. Yeah, look at that. Isn't that nice? Yeah. So again, like, this is both abstract and very real, right? And so you can see how the meta structure shows the archetype, and then we get the stuff in motion and time passes, and we have pulsative asymmetries, which make everything a little bit messy, but nonetheless arises in accordance with these natural laws. And because space itself has a specific shape, it can only happen in these ways. Natural is what nature allows. And so it can only happen in this way. Something unnatural wouldn't happen because that's not the way reality is structured. So yeah, there's an inevitability to all this, which is actually really, I find it both satisfying and claustrophobic sometimes, right? Where it's like, it's all connected, it's amazing, like, it's all connected, can't escape from it. Like, oh, but there's something really satisfying in that there's order to it. It's not random. It's not just this big mistake just chaotically arising. There is this underlying order that structures reality.
So it's safe to say there's nothing that's unnatural?
Yes, I would say that there's nothing that's unnatural.
Just get rid of that word.
Yeah. Okay. Yeah. And of course, that's on like a very meta level.
Yeah.
Because there are things that I would argue that humans do that are unnatural, in that, like, we are the one species privileged to deny our own nature, right? And we go against it all the time. And that's, again, part of this work is to recognize and step into and activate our fully three-dimensional nature and behave consciously in better alignment with these natural principles. Because there's something unique about humans where we have the choice to, like, pretend that we're outside of the system of creation, maintenance, and destruction, right? Oh, we don't need to compost. We can just put everything in a big dirty pile over here and that'll be fine. It's like, no, it's not. And the trick is that those natural principles are going to operate whether we like it or not. Like, thank goodness existence doesn't depend on human belief or understanding to function properly, right? Like, just because people used to think, or still do think, the earth was flat doesn't make it actually flat, right? Thank goodness. And so whether we're aligned with the order of the cosmos or not, if we can be out of alignment for so long, right? Like, you can be sick for so long and be fine, I'm fine, I'm fine, until you're not. And so there's a ominous sense in the world that I perceive these days that we're getting to that point where, like, it's fine, it's fine, it's fine. And we're not fine. We're not fine. And so this is sort of the urgency of this work as well, is to control what we can control, which is mostly just our own personal bubble. But if we can organize that in alignment with larger superstructures, then, you know, it's all just a set of nested spheres. And so if one clicks into place, the next clicks into place, the next, and has this cascading effect. So that's ultimately the large, bigger picture goal of this information, the practical application of it, and this work, that all the practices that follow from this sort of like theory and data. Sound good? Doing it? Okay, great. Okay, so we made it to the third dimension. Let's see if there's anything else we want to say about that. The qualities of this dimension are relatively familiar because it's reality. We see it all around us. And we mentioned this culturally. We're accustomed to assuming that 3D space is empty. Like we said, like, the room is empty. There's a bunch of empty space here. But Arthur Loeb, who's this amazing scientist, I don't want that to be there anymore. Let's put that there. I wonder if I can hide that. Floating meeting controls, science. Okay. Arthur Loeb, born in 1923, died in 2002. He was a Dutch scientist. He was an MIT professor. He collaborated with Buckminster Fuller and M.C. Escher. He was big into design science and visual geometry. He's amazing. His book, Space Structures, is one of the most mind-blowing books I've ever seen. Excuse me. And in that book, Space Structures, he says space is not a passive vacuum. Space has properties that impose powerful constraints on any structure that inhabits it. These constraints are independent of any specific interactive forces, hence geometrical in nature. So space has properties. We've looked at some of the ways that space can only look a certain way, and we're going to go deeper into that in part 7. But so we'll go deeper into that, but specific interactive forces, what are those? Talking about things like time, gravity, electrical force, you know, things that move through time and space. And so these energetic forces do not influence the shape of space. Space itself, the shape of space is prior to these interactive forces. And so we can look, so they're geometrical in nature, right? And so independent of size, actually, size, weight, independent of gravity, because you can take a tetrahedron and it has the same relationships of force and tension, whether it's, you know, 1,000 feet tall or microscopic, right? Same fundamental relationships. And then you can start adding forces of gravity and time and pressure on it, but it's still going to be structured the same way. So these are the structures of space, geometrical in nature. So in the next section, we're going to talk about the 5 very special shapes, which are the primary organizing structures. There's only 5, and we'll dive into these properties. So before we do that, pause for questions, comments, confusion, enthusiasm.
I've never thought about this before, that there's like an architecture underneath matter.
Mm-hmm.
It's really fascinating.
Hmm.
I'm excited to get a conception for what this looks like.
Yeah, beautiful. Did you guys on the Zoom, you guys hear that? Yeah, okay, cool. Yeah, there's a subtle architecture. Empty space is not empty. And this is like a known thing. But again, like that's not what was taught to me in my AP physics class in high school, or in 6th grade. Like this is the sort of thing that again, like this work has vast implications and applications, but for me it's like, why didn't we learn that in 1st grade? Right? Literally a 1st grader could comprehend everything we just did. It's shapes and dots and lines, and the origins of Buckminster Fuller's genius. When he was just a little child in elementary school, he had like terrible vision. Like I think he was legally blind. He had these Coke bottle glasses his whole life. And so because when he was little, it was before he got those glasses, before it was recognized that he was basically blind. And so in class, they were doing this activity to build a standing structure, and they had little cotton balls or little foam balls and toothpicks, and you're supposed to stick the toothpick and build a 3-dimensional structure. And all the other kids built a cube, because visually a cube is like the simplest way to make something that stands. Buckminster Fuller, because he couldn't see, he did it all by feel and imagining in his head, and he created a tetrahedron. And that experience was a formative moment in his, like, he went on his book Synergetics, which I have sitting on the table here. It's like a 10-pound book. Here, let's just show it to the Zoom. It's like weighty in so many ways. And that book, basically he builds a new system of geometry from scratch based on these organic principles. And his assertion is that the way we do geometry and the way we structure space based on a cube is inefficient. It's fundamentally, it's functional, but it's not the only way to do it. And it's not the way nature does it. Like, how many right angles do you see in nature? Like, sometimes there are crystals that show up that way, right? But things tend to be more radial than angled and straight lines. So it's more circles and spheres and that sort of structure than it is. So anyway, we're gonna keep going into that. But yeah, it's a great point. I've never thought of it this way. And this is the revelation. It's like, wait, this is so fundamental to everything. Why are we not talking about this? Why are we not sharing it in this way? So that's why we're here.